This topic is about solving equations simultaneously to find the points of intersection of a curve and a straight line. This might be in the form of a worded problem where the equation needs to be set up algebraically first. Feel free to pause as I go through some examples. Now the first thing I need to do is label the equations 1 and 2 and identify which one is linear and which one is non-linear. Now the linear one always involves just x and y, or just terms without indices. And the non-linear is obviously the one with the x squared term. Okay, in this case the non-linear one is a quadratic. So what you need to do first is rearrange the linear one to make either the x or the y the subject of the formula. So if I've got x plus y is equal to 8 from equation 1, then that means if I make y the subject of the formula, then y must be equal to 8 take away x. Now I need to substitute y is equal to 8 take away x, which is what I just found out, into my non-linear equation, so which is 2. So my equation 2 is obviously y is equal to x squared plus 2x plus 4. So if I replace y with 8 minus x, I get 8 minus x must be equal to x squared plus 2x plus 4. If I take everything to the right hand side because I want a positive x squared, I get x squared plus 2x plus 4 minus 8 plus x must be equal to 0. If I simplify it, then I have, I'm just going to rewrite it in this way, x squared plus 3x take away 4 must be equal to 0. Okay. Now I have to factorize it. So when I'm factorizing, I'm looking for two numbers that multiply to give me negative 4, add to give me 3. That must be positive 4 and negative 1. So either x plus 4 is equal to 0 or x minus 1 must be equal to 0, which means x equals negative 4 or x is equal to 1. Okay, so now I need to substitute to get my corresponding y values. So substitute x equals negative 4 into y is equal to 8 take away x. I get 8 take away minus 4, which gives me 12. In a similar way, if I substitute x equals 1 into the same equation, y is equal to 8 take away x, then I get 8 take away 1, which is equal to 7. Which means my solutions are x equals negative 4, y equals 12, or x equals 1, y equals 7. Or you can write it as minus 4, 12, and 1, 7. So these are my points of intersections for that line and curve. Okay, let's move on to a second example. Okay, so find the points of intersection of the line and the curve. You've got a more complicated curve, which is an ellipse here. So again, recognizing which one is linear and which one is non-linear. So I've got 2x minus 3y is equal to 3. That's my equation 1, which is the linear one. X squared minus 2xy plus 3y squared is equal to 6, which is my equation 2, which is non-linear. Okay, so remember I need to rearrange my linear equation to make either x or y the subject of the formula. So I'm going to make x the subject of the formula for my equation 1. So if I've got 2x minus 3y is equal to 3. This implies 2x must be equal to 3 plus 3y, which implies x must be equal to 3 plus 3y over 2. Okay, so now I need to substitute x is equal to 3 plus 3y over 2 into the second equation, which is 2. So everywhere I see an x in my second equation, I replace it with 3 plus 3y over 2. So once I do that, I do get 3 plus 3y over 2 squared minus 2 times 3 plus 3y over 2 times the y, don't forget the y, plus 3y squared is equal to 6. Okay, if I expand the top, 3 plus 3y squared, I end up getting 9 plus 9y plus 9y plus 9y squared, all over 2 squared, which is 4, minus, okay, if I look at this term, the 2 and the 2 here will cancel up. So all I'm left with is 3 plus 3y times y plus 3y squared is equal to 6. Okay, now what I'll do is I'll collect the terms on the top and I can and expand the bracket on the second term. So I get 9 plus 18y plus 9y squared over 4 minus 3y squared plus 3y squared is equal to 6. So this and this will cancel out. Now I don't like this 4 at the bottom, which means I'll times it by 4, everything by 4. But that means I need to times every term by 4. So what I end up getting is 9 plus 18y plus 9y squared. Because I've multiplied by 4, I get rid of the denominator. Minus 12y must be equal to 24. Now all I need to do is rearrange it and get everything to one side. So I get, and so 18y take away 12y gives you 6y squared. So I get 9y squared plus 6y. 9 take away 24 gives me minus 15. So I end up getting this. And I realize there's a common factor of 3 running throughout, obviously, so I need to divide by 3. So I get 3y squared plus 2y minus 5 is equal to 0. So I got to a point where I need to factorize this. This looks like it's going to factorize. So if I factorize it, I'm just going to go move here. I'm looking for, the only way to make 3y squared is 3y times y. I need to make sure I have two things, this and this multiplied to give me negative 5. And then the middle terms gives me also 2y. So using trial and error, I realize this must be plus 5 and minus 1. So if you look at it, 5 times minus 1 does give you negative 5. From the middle terms, I get negative 3y plus 5y, which gives you positive 2y. So using trial and error in this case. Okay, which means y is equal to negative 5 over 3 or y is equal to 1. Now don't forget you need to find your corresponding x values. So I need to substitute back into x. So substitute y is equal to negative 5 over 3 into x is equal to 3 plus 3y over 2. So what you end up getting is 3 plus 3 times negative 5 over 3 over 2, which is the same thing as 3, take away 5, divide by 2, which gives you negative 1. Similarly, you have to substitute y equals 1 into x is equal to 3 plus 3y over 2, which gives you 3 plus 3 times 1 over 2, which gives you 3. Okay, so your solutions are x is equal to minus 1, negative 5 over 3, and x is equal to 3, y is equal to 1. Okay, so that would be your solutions for that one. Okay, and the next question, if you look at it, it's a worded problem. Okay, it says the sides of a cuboid measure 1 centimeter, A centimeters and B centimeters. Its volume is 12 centimeters cubed and its surface area is 38 centimeters squared. Find A and B. So if I draw out the cuboid roughly, then one side is equal to A centimeters, B centimeters here, 1 centimeter there. Okay, now the volume of a cuboid is length times width times height, which is equal to A times B times 1, which is equal to AB. Okay, the surface area is all the faces added, the area of all the faces added together. So this face, if you do the first face here, A times 1, so this gives you A. This face is B times 1, which is B. And the top face is A times B, which is AB. Now don't forget you have 6 faces, so you have to double them. So it's 2 times A plus B plus AB. Okay, if you want to expand that out, that gives you 2A plus 2B plus 2AB. So if I set up my first simultaneous equation, I get volume AB must be equal to 12. And the surface area one tells you that 2A plus 2B plus 2AB must be equal to 38. Okay, this is equation 1. Label it as equation 1 and equation 2. Okay, now it's easier to rearrange equation 1 to make either A or B the subject of the formula. So I'm going to rearrange the first equation. AB is equal to 12 implies that B must be equal to 12 over A. Okay, so now what I need to do is substitute B is equal to 12 over A into equation 2. So when I do that, I get 2A plus 2 times 12 over A plus 2A times 12 over A must be equal to 38. Okay, if I simplify this, the first term stays as 2A. Second term becomes 24 over A. The A and the A in the third term cancel out, so I'm left with 24 is equal to 38. If I take everything to the left-hand side, I get 2A plus 24 over A. 24 take away 38 gives me negative 14 is equal to 0. Now I don't like that A in the denominator for the second term, so I'm going to multiply everything through by A. So I end up getting 2A squared plus 24 minus 14A is equal to 0. I see there's a common factor of 2 throughout, so I can divide through by 2, and if I rearrange it, I get A squared. The negative 4A becomes negative 7A, and the positive 24 becomes plus 12 is equal to 0. Okay, now I need to factorize it. Okay, two numbers that add to give you, multiply to give you 12, add to give you negative 7. It must be negative 3 and negative 4, which means A is equal to 3 or A is equal to 4. If A is equal to 3 or B is equal to 4, then since the equation tells us B is equal to 12 over A, so B must be equal to 4 or B must be equal to 3. So my two solutions are A equals 3, B equals 4, or A equals 4, B equals 3. Which makes sense because they can interchange you. That would be the same thing. Okay, the last thing I want to go through is how many solutions do you get when you solve things simultaneously? So the first question says, if you were to solve the equation of two straight lines simultaneously, the number of solutions could be. So how many solutions could you get? So if I have my first equation of a line, and if I have another one, then my other equation could look like this, which means they're parallel, which means they have 0 solutions because they do not cross at all. Okay. Now another scenario might be that they do cross, but they cross only at one point. A different scenario might be is they do cross, but they do the cross at every single point, so they have infinite solutions. Okay, let's try the same thing. With the equation of a circle and a quadratic. So I'm just going to draw the circle because it makes it easy if I just draw it out. So if I have all the scenarios I can get. Okay, let's change it, the quadratic to red color. Okay, so I can have the scenario where my quadratic looks like that, crosses it like that. So that means I have 1, 2, 3, 4 solutions. I can have the scenario like this, where it touches it at one point there, so I get 3 solutions in this case. I can have this case where it crosses it at 2 points only. Or it touches it here, which means they have 1 solution. Or it doesn't touch at all, so it's somewhere floating above it, which means there's no solution. So just because you have a quadratic and an equation of circle in front of you, it doesn't mean you're always going to get 4 solutions. Sometimes you're going to get 0, 1. So there are all these scenarios to consider. Okay, and the last one that we look at is what happens when you have 2 quadratics in front of us. So let me just draw some quadratics in front of you for all the different scenarios you can get. Okay, so first of all, you can have that they don't touch at all, so they're away from each other, so which means you have 0 solutions. You can have the case like this where it touches it at one point only, so you have 1 solution. The next situation you can have is where it crosses it in 2 places. That will be 2 solutions. And there is a 4th scenario where it's exactly the same quadratic, so you have infinite solutions. So something to keep in mind when you're solving equations simultaneously. Don't always expect a certain number of solutions. You might find 1 solution even though you have a quadratic involved.